Hello everyone. I'm going to talk about learning-based, efficient and fast access methods for beyond 5G wireless communications. In my research consists of three main parts. First one is massive number of devices. That means a massive number of sensors and actuators. And I'm going to use where it can be applicable in indoor factories and indoor universities, any indoor scenarios which can be applicable. And especially I'm using AI/ML technologies to solve the problem. So collectively, that's my research idea. Then consider the system model and architecture. Initially, just imagine in 90s 50 to 70, initially human did not have much computational power and all. Mostly human intelligence plays a role. Then later start using lot of machineries and computational power in 90s to today. We have some certain level of factories. Now we are thinking with the advanced wireless and facilities and technologies, we are thinking about ever-changing factory. That means we build the factory, and if we want to change the factory floor, we want to change according to our need. So here, what it changed is intelligence from human intelligence to machine intelligence. So I take a system from the ever-changing factory. That means the system consists of massive number of devices. So each work with the grant-free NOMA, which is conventionally better than the conventional architectures and all. So that means the base station does not know what are the devices are active in every time scale. And some of the devices are active, some are not active. And we are using two different kind of signatures. So SCMA, it's introduced by Huawei, and ZMUSA, which introduced by ZTE. Simply, you can take them as a IDs of name of the devices. So then the challenge is to identify the active devices. That means what are the devices and how many devices are active. So then mathematically formulate the problem as a sparse signal recovery problem, which is well known and studied for several decades. What I did is to convert the problem into multi-label classification problem. So in each entries of data have different numbers of devices and their identity varies. So how I solved this, I took the inspirations from the well-known ResNet architecture and proposed the solutions to have an advanced solution for the problem. So in a results point of view, initially we compare the results with the probability of detections versus SNR, how it varies with two different code books and overloading ratios here. The overloading ratio is the ratio between the number of resources and the devices. And likewise, I compare the results and investigate the results with the record versus device activity. That means how many, when the device number of devices are increased, whether the performance increase or decrease and all. So collectively we observe very good performance with our proposed ResNet based architecture. So what our next target is to build the most realistically environment for the factory floor. So as a first step, investigate especially correlated Ricean channel, which is proven as a mostly suitable channel condition for indoor scenarios. So therefore, I studied those topic with a well-known vision transformer architecture and see the performances and also collectively which is better than even the ResNet, and it's well addressed the spatial correlation as well. So then most realistically we move closer to see we collect the real data in SCW factory and investigation going on how to see with the AGVs are moving with the dynamic scenarios and also this is overall picture of our research. Thank you.